Hi guys, I hope that you have watched my previous videos on concepts. So if you are thorough with the concepts, then we can start to do some problems. So here we have a problem which says prove by vector method that if a line is drawn from the center of a circle to the midpoint of a chord, then the line is perpendicular to the chord. So let's draw the diagram. So this is our circle, and OA and OB are two radii from the origin O, and OC is a vector which divides the chord AB exactly into two equal halves. So I can say that OA is equal to OB because both are radii. Okay, next we can define vector OA as A and vector OB as B. Then our vector AB can be defined as vector OB minus OA vector. Vector AB can be defined as minus of OA because OA is in this direction, so minus of OA will be this direction. So OB minus OA. Okay, so I hope this is clear. So don't try to memorize this, always try to understand what you're doing. Next, we can further define our vector OC as, since OC divides AB exactly into two halves, so using the section formula we can call this as vector A plus vector B divided by 2. So this will be vector A plus vector B divided by 2. Okay, to prove that OC is perpendicular to AB, so this is what we have to prove. So what we need to do is we have to show that our OC dot product with AB is equal to 0. So let's start working on this. So this is what we need to prove. Okay, so OC dot product with AB will be equal to, what is our OC? OC is given by A plus B by 2. So vector A plus vector B divided by 2, and our vector AB is OB minus OA. So that is, which is B minus A. So further simplifying, I can take the 1 by 2 common and call this as vector A plus B dot product with vector B minus A. And that's equal to 1 by 2 into, using our formula A plus B into A minus B is A squared minus B squared, we can say that this is equal to vector B dot product with vector B minus vector A dot product with vector A. And we know that vector B dot product with vector B is equal to magnitude of B into cos theta, where theta is the angle between B and B, which is 0, so cos theta will be 1. So you get this as B squared. So applying that here, half into B squared minus A squared. Now we know that since OA is equal to OB, our B squared minus A squared will be 0. So the answer is 0. Therefore, since OC dot product with AB is equal to 0, we can say OC is perpendicular to AB. In this problem, it says prove by vector method that the median to the base of an isosceles triangle is perpendicular to the base. So I've already drawn the diagram for you here. So this is an isosceles triangle and the median is the line OC, which connects the midpoint of AB at C. Alright, so OC is the median of the triangle. So we know that since it is isosceles, OA is equal to OB. Both sides are equal. So C is midpoint of AB. So if we take O as the origin and define vector OA as vector A and vector OB as vector B, then our vector OC can be defined as A plus B divided by 2. Okay, because it divides AB exactly into 2 equal halves. Now we need to show that OC, to prove OC is perpendicular to AB. So for this we need to show that our OC vector dot product with AB vector is equal to 0. Okay, so let's try and do that. So OC dot product with AB can be written as, we know that our OC is A plus B by 2 dot product with AB vector. AB vector can be defined as vector AB is equal to OB minus OA, which is equal to B, vector B minus vector A. So dot product with B minus A. So again, for the simplifying, we can say this is equal to half of vector B dot product with vector B minus A dot product with vector A. And that would be equal to half of B squared minus A squared. Since B is equal to A, since it's isosceles, the magnitude of OA and OB will be equal. This will become 0. Therefore, OC is perpendicular to AB. Let's see the next problem. The problem says prove by vector method that an angle in a semicircle is a right angle. So I have sketched the drawing for you here. So we have a semicircle with A and B as the diameter, O as the center or the origin of the circle, and P is any point in the circle. So we can say that our OA is equal to OB and that is equal to OP because they are all the radii of the circle. So AB is the diameter, O is center of the circle, P is any point on the circle. to prove that angle APB is equal to 90 degrees. Yep. So our vector PA can be defined as vector PO plus OA vector. Okay, vector PA can be defined as PO plus OA vector. Similarly, vector PB can be defined as PO plus OB vector. But we know that OB vector is equal to minus OA vector because they are in the opposite direction but same magnitude. So we can say our PB vector is equal to PO vector minus OA vector. So if we do the dot product of PA and PB, so this is our PA, this is our PB, we get PO plus OA dot product with PO minus OA vector. So we can further write this as PO vector dot product with PO vector minus OA vector dot product with OA vector. So that would be equal to the magnitude of PO squared minus the magnitude of OA squared, and that's equal to 0 since PO magnitude is equal to OA magnitude because they're both radii. Therefore, PA vector is perpendicular to PB vector. Therefore, angle APB is equal to 90 degrees. In the next problem, we have to prove by vector method that the diagonals of a rhombus bisect each other at right angles. So let's call A, B, C, D a rhombus. So A, B, C, D is a rhombus. So which means AB is equal to BC is equal to CD is equal to DA. We have to prove that BD is perpendicular to AC, which are the diagonals. So using vector, we need to say that BD dot product with AC is equal to 0. So let's start defining them. Vector AC is equal to AB vector plus BC vector. So you have that AB plus BC. Similarly, vector BD is equal to BC plus CD vector. BC plus CD vector. Now we can see that CD is in this direction and AB is in this direction, but their magnitude are the same. So magnitude of AB and CD are same but in the opposite direction. Therefore, we can say BD is equal to BC minus AB vector. Since CD vector is equal to minus AB vector. So BD dot product with AC will be equal to BD is BC vector minus AB vector dot product with AB vector plus BC vector. So this can be written as BC vector dot product with BC vector minus AB vector dot product with AB vector, and that will be equal to magnitude of BC squared minus magnitude of AB squared. So we know that BC is equal to AB, the length BC is equal to AB, therefore we can say this is equal to 0. So therefore BD is perpendicular to AC and the diagonals bisect each other at right angles. Thank you for watching Math Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.